Hey, Algebra 1. We're going to graph some linear inequalities. You should already have the note sheet for this. If not, please make sure you grab one from the sub or grab one from Classroom. You can either print it out or you can obviously type these things in, but it's kind of hard to type things in when you're watching the video. So, graphing linear inequalities. We're going to review graphing lines, and we're adding one more component to it, and then from there, you'll have some practice to do. So we'll probably finish most of this up today and then practice tomorrow. So, as you warm up, which of the following are solutions to this inequality? Pause the video, answer this, and then start it back up to check. Now, as I believe, okay, so the only one that here works is -6. -5 is equal to it. -4 is bigger than it. -3 is to it. And if you're not sure about that, I mean, graph it out. I've got 0 here. Here's -5. So -4, -3 would be up over here. -6 is over here. Less than means that we're going this direction. And since it's not less than or equal to, -5 doesn't work. Okay, again, I want you to graph this line. So pause this first, graph the line, and then go ahead and double check it. All right, hey, so first thing that you need to do is put this into slope-intercept form is the easiest way. So you get that. So your slope is -1/2, your y-intercept is 3. So again, remember, x-intercept, y-intercept, I'm going to go up 3. And your slope, remember, change in y over change in x. So I'm going to go down 1 to the right 2, down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. And go from there, and then take out your line drawing tool, called a ruler or your ID, and boom, there you go. And that's what we're going to end up spending some time on doing today. So it's going to be a good chance to review a bunch of stuff from first semester. Your essential question, can I graph a linear inequality? Now we've graphed inequalities, so we're going to graph lines, and we've graphed this. So this looks like this. Graphing an inequality is where you do the number line and you have the circle and you shade. So now we're going to combine these. Okay. Definition is linear inequality of two variables, similar to a line. But the line may or may not be included. And I'm going to relate it to the open circle or the filled-in circle. And that's what the boundary line is. One side, oh, before I forget, one side is shaded. And that's going to be where all your solutions are. The boundary line separates the solutions, solutions from non-solutions. Again, pause where you need to. So your steps here are going to be the following. So for example, if I was graphing this equation, the first thing you need to do is determine whether or not you'll have a solid or a dotted line. The solid line happens when there's equality. So like here, there's equality built in because it's greater than or equal to or less than or equal to, so those have to be included. All right, so that's going to be a solid line, just like a normal line, because you'd graph it. If it was y equals a number, you'd graph that line. Now, when it's greater than or equal to, it's going to be the line will be dotted because that y equals the line isn't included. But everything up to that would be included. If you remember when we did that whole, I'm not touching you, the little brother theorem, and you know how they only get super close to your head, but they don't actually touch you? That's it. So then you're going to graph this equation like you normally would. Okay? So you graph it like with an equal sign, so you'd have y equals 1/2 x minus 4. The only thing is that you would do a dotted line or a dashed line depending upon what, or a dotted line or a solid line depending upon what the equality was. So like in this case here, step 1, we're going to use a dotted line because there's no equality with the greater than sign. Step 2, we're going to graph this. So slope is 2, technically 2 over 1. Your y-intercept, oops, I skipped step 3 before, is at 0, -5. Let's back up one step, sorry. Whoa, it's way down there, sorry. So step 3 would be find a solution point that makes the inequality true. So first check the origin 0, 0. So back here, you know what, let's do this. Copy that out. Oh, get a graph. All right. So, solid line. My slope here is going to equal 1/2. My y-intercept is going to be at 0, -4. So we're going to go ahead and plot this line. I'm at 0, -4, which is right there. Go up 1 to the right 2, up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. You can draw a solid line here because there's the equality. So now you're going to find a solution point because, again, what's going to happen here is either all of these points over on this side are true, or all of these points are going to make this inequality true. So we need to find that out. Okay? So the way that you do that is you find a point and you're going to plug it in. This is part of the reason why we've been plugging in and testing solutions before. So we're going to test this. So is 0 less than or equal to 1/2 of 0 minus 4? So this is going to become 0. So is 0 less than or equal to -4? No. Now if we look back up over here, 0, 0 is right here. That point we just found out does not work, which means that all of the points, any of the points over on above this line do not work. So that means that all the solutions down here will work. So we're going to shade in all the way over here. And that's the last part, step 4. Shade the region with the point, with that point in it. So 0, 0 doesn't work. So let's try one of these over here. Okay, so we try, let's say, check 0, -6. So if I plug that in, notice what happens. -6, is that less than or equal to 1/2 of 0 minus 4? So a -6 is less than or equal to 0 minus 4. That's true. So that's why any of these points over here work just fine. Now, what I did there a little bit fast, I got 0, 0. That didn't work, and that would mean that all the other points on the other side would work. Okay? So let's get back to this one. Sorry. So we're going to graph this line. It's going to be a dotted line. We're going to go down here to 0, -5. We're going to go up 2 to the right 1, up 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 to the right 1, etc., etc., etc. We're going to draw our dashed line. So again, what's going to happen means that any point on that line is not going to be a solution. Every point on that line is not a solution to this. However, every point on one side of that line will be a solution. So again, check 0, 0. If true, we're going to shade. On that side. So 0 is y. Is that greater than or equal to 2 times 0 minus 5? Is 0 bigger than? So this is 0 minus 5. So 0 bigger than negative 5. That is true, which means at this point 0, 0 is part of the solution set, which means that every single point over on this same side will work. You can pick any of these points and plug them into this equation here, and it's going to make them work. So step 1, determine you need a dotted line. Step 2, graph the line. Step 3, test the point. Step 4 was shade. Again, pause and rewind whenever you need to when we're doing this. Okay, we're going to practice that skill there in step 3. So first of all, we're going to determine whether or not negative 3, negative 5 is a solution of that inequality. The opposite of x minus 3y is less than 18. Explain why or why not. So this is x, this is y. So I'm going to take the opposite of negative 3. Now, if you're the person who is saying, well, it's already negative. No, you're taking